All right, so we've got the unit circle down. Now let's talk a little bit about some of these trig functions. What we're trying to help you understand is we're talking about a terminal point on the unit circle, and you can always, in any quadrant, construct a triangle. You've got a reference angle, which our reference angle here is going to be t. And if you think about it, if I said what's the coordinate to this point, this is your x coordinate and this is your y coordinate. So what we're going to do is we're going to use all of the trig functions that we have in terms of x and y. And remember, if you're on the unit circle, the hypotenuse is 1. So I'm going to draw that again on the next page and we'll reference it. We have x, we have y, and the hypotenuse is 1. So if this is my angle that I'm referring to, t, my reference angle, if I say what's the sine of t, you would say opposite over hypotenuse, y over 1, which is just y. Cosine of t is adjacent over hypotenuse, so x over 1, which is just x. Tangent is opposite over adjacent, so y over x. Cosecant is the reciprocal of sine, so instead of opposite over hypotenuse, we'll say hypotenuse over opposite, or 1 over y. Secant is the reciprocal of cosine, so instead of adjacent hypotenuse, it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so instead of opposite adjacent, we're saying adjacent over opposite, which is x over y. You can also just flip this. If this is tangent, you know that's cotangent. If this is sine, you know this is cosecant. If this is secant, you know that's cosine. Now, there are certain times that you will not be able to evaluate some of these functions. Sine and cosine, you can always evaluate. So we'll say all real numbers, or if you want to use interval notation, we'll say negative infinity to infinity. Same thing with cosine. You can take the cosine of whatever you want. Okay, so cosine and sine, there's no restrictions, there's no domain restrictions. But all these other ones have a denominator. So what you got to remember is, for tangent, x cannot be 0. So think about where that would happen. Where would x be 0? If you have an xy pair, x is 0 on the y-axis. So that's right here and right there. That means that t cannot be, that's color, I can't see that. Oh, we're down here anyway. T cannot be up here, which is 90 degrees, or t cannot be down here, which is 270 degrees. Now, if tangent can't be either of those things, then notice the other time that happens when x is in the denominator is right here. So tangent and secant have the same domain because x can't be 0. So t can't be 90 and t can't be 270. Same thing with cosecant. These both have a y in the denominator. So where this, we're just going to say y can't be 0. But where does that happen? Where is y 0? That's where you're on the x-axis. So that would be at 0 degrees, t can't be 0, or t can't be 180. And you can also throw 360 in there if you want. So t can't be 0, 360, or 180. You can't take the cotangent of 0 degrees because the cotangent would be 1 over 0. And 1 over 0 doesn't work. Okay, so what we're trying to do is start to picture these in terms of x and y, because now what I can do is find all 6 trig functions if you give me which one you want. So what I'm going to do is draw it, say, all right, 90 degrees. 90 degrees is right here. And that happens at 0, 1. If you're on the unit circle, it's at the top. So 0, 1, this is 90 degrees. So what's the sine? Remember, sine is the y-coordinate. So in this problem, the y-coordinate, oops, oh, wait a minute, wrong way. Sine is the y-coordinate. So if I say what's the y-coordinate, the y-coordinate is 1. Cosine is the x-coordinate. Cosine is x. So what's the cosine of theta, or t in this case? 0. Cosine is the x. What's tangent? Tangent is y over x. So 1 over 0. Wait a minute. 1 over 0, that is undefined. You cannot take the tangent of 90 degrees. Like we said back here, you can't take the tangent of 90 degrees because x is 0 and you can't divide by 0. So if you do y over x, 1 over 0, you get undefined. Cosecant is the reciprocal of sine, so the reciprocal of 1 is 1. Secant is the reciprocal of 0, so 1 over 0, wait a minute, for the same reason, this is undefined. If tangent's undefined, secant's going to be undefined. Cotangent is the reciprocal of tangent. Now this, you got to be careful. So instead of y over x, this is x over y, which is 0 over 1. That's 0. So you can find the cotangent. You could also think about flipping that. Instead of 1 over 0, make it 0 over 1, and that's something you can evaluate. Let's try another one. Negative 60. All right, so negative 60 means we're going to go proper clockwise. Negative means instead of going counterclockwise, we're going to go to the right, or I'm sorry, I guess I should say clockwise, 60 degrees. So below. This is 60 degrees. So let's remember, across from 60 is radical 3 over 2. If this is 30, then across from that is 1/2. And in the fourth quadrant, y is negative. So the sine is the y-coordinate. The y-coordinate is negative radical 3 over 2. Cosine is the x-coordinate, 1/2. Tangent is opposite over adjacent. So this you got to be careful. And you're going to do this enough that you'll probably just remember it, but let's go through opposite over adjacent. We have negative radical 3 over 2 divided by 1/2. So opposite over adjacent. So now we're going to copy, change, flip. This is negative radical 3 over 2 times the reciprocal is 2 over 1, and those will cancel, and you'll just get negative radical 3. So this is negative radical 3. What I would suggest you remember, because you're going to see this all semester, is if you have a 60-degree reference angle, tangent's going to be radical 3. In the fourth quadrant, it's negative. Cosecant is the reciprocal of sine, so this is negative 2 over radical 3, but you need to rationalize that. So this is negative 2 radical 3 over 3. Secant is the reciprocal of cosine, so that's just 2. That's nice. And cotangent is the reciprocal of tangent, so 1 over radical 3, which, again, you need to rationalize to get radical 3 over 3. And again, it's still negative. These numbers you're going to see all semester. Like this guy, and this guy, and this guy. They happen all the time because you're always dealing with this triangle, 30, 60, 90. So you see these angles, these points a lot. Last thing, let's see if we can figure out what would be positive and what would be negative. So in the first quadrant, x is positive and y is positive. So we're going to say everybody's positive. Sine, cosine are both positive because this is plus plus. If they're both positive, then you go back and think, well then, positive, positive, the ratio would be positive, ratio would be positive, positive. Yeah, they're all positive in the first one. In the second quadrant, you have negative x's but positive y's. So remember, y is sine. So this would be sine is positive. So the sine of the angle will be positive. And then similarly, the cosecant will be positive. Because if you just take the reciprocal of positive, you still get positive. Here it's negative, negative. So that means, let's see, sine is negative, cosine is negative. So what's positive? Well, if you divide them, like y over x, that would be positive. Because a negative divided by negative is a positive. So the tangent is positive, which means also the cotangent is positive in the third quadrant. In the fourth quadrant, x is positive, y is negative. So x is cosine, that means cosine is positive. And then its reciprocal secant is also positive. Tangent will be negative because a negative divided by positive is negative. So the way some people remember this is ASTC, or all students take calculus. If that helps you, great. Remember that. So that's what's going to be positive in which quadrant. And now last thing, I've got a little question here. It says, if you're in quadrant 2, what would happen if you multiply the cosine times the tangent? So in quadrant 2, cosine is negative. It's the x. So cosine, that would be a negative number. And in quadrant 2, tangent is also negative because positive divided by negative would be negative. So their product would be a positive number. We're going to do more of that stuff later. But you should be able to tell me whether x or y is positive in each quadrant, and then hopefully now you can relate x and y to your trig functions. And that's it, so be sure to hit like and subscribe.